students. So we are continuing this exercise 6.1 from question number 6 part 2. Okay, so question number 6 part 2, limit x tending to 0 2 tan inverse x minus x divided by 2x minus sine inverse x. Now we need to check the form, okay, whether it's 0 by 0 or not. So therefore just put the value for x equals to 0 out here, 0 out here. Tan inverse 0 is 0, x is 0, x is 0, sine inverse x is also 0. So all in all we are getting 0 by 0 form. Okay, so therefore by LH rule, differentiate tan inverse x. So 2 into 1 by 1 plus x square minus 1 divided by 2 minus 1 by root of this. Okay, so differentiating tan inverse x, sine inverse x and x. Okay, so now I'm getting this back, isn't it? So now when I put the limit out here, check the limit, I will not be getting 0 because 2 divided by 1 plus 0. 1 plus 0 is 1, so I'm not getting 0. Even 1 minus 0 is 1, I'm not getting 0. Okay, so then finally when I put the value, finally I have to remove the limit. So remove the limit, wherever it is x you put 0. Okay, 0, and simplified, this is 2 divided by 1, that is 2 minus 1, and this is 2 minus 1 by root 1 is 1, so 2 minus 1, 2 minus 1, so that is 1 by 1, which is equals to 1. Okay, so I'm pausing the video, note down the solution. So I'm now moving question number 8 part 1. So question number 8 part 1, if you see, we have limit x tending to 0 and x minus sine x divided by x cube. Okay, so we need to check the form. So denominator is 0, x is 0, sine 0 is also 0, so the form is 0 by 0. So therefore by LH rule, limit x tending to 0 1 minus cos x divided by 3x square. Okay, now again you check the limit, 1 is 1, cos 0 is 1, 1 minus 1 0, and this is again 0, so again it is 0 by 0 form. So whatever is the constant we'll take it outside, so 3 is a constant, so 1 by 3 will be outside. 1 by 3 limit x tending to 0 1 minus cos x divided by x squared, this is 0 by 0 form. Okay, again we'll use LH rule, by LH rule. So 1 by 3 is already a constant, limit x tending to 0, differentiation of 1, 0 minus differentiation of cos x is minus sin x divided by 2x. Okay, so 1 by 3, so 1 by 3 limit x tending to 0, minus and minus plus, so this is sin x by 2x. Okay, again 2 is a constant, take it outside, so 1 by 3 into 1 by 2 limit x tending to 0, I will be getting sin x by x. Okay, limit x tending sin x. Now this is the standard limit, this is the standard limit, and the value for this limit is directly 1, so 1 by 6 into the value for this is 1, so hence the answer is 1 by 6 only. Okay, so let us also understand about the standard limits now. So when we do this indeterminate form, this chapter, we have to come across these limits. Okay, limit x tending to 0 sin x by x, or limit x tending to 0, just the opposite, x by sin x, both of the limits is equals to 1. Okay, even this one, limit x tending to 0 tan x by x, or limit x tending to 0 x by tan x is also is equals to 1. So while calculation, if we got this limit, the value for this will be straight away 1. Okay, now how it is 1? Let's say limit x tending to 0 sin x by x, you put x equals to 0 in the numerator and denominator. Denominator is 0 and sin 0 is also 0, so hence it is 0 by 0 form. So once it is 0 by 0 form, you again apply LH rule, differentiation of sin x will be cos x, differentiation of x will be 1. So only I'll be getting limit x tending to 0 cos x, isn't it? And limit x tending to 0 cos x, if you put x equal to 0, it will be cos 0, so cos 0 is 1. Same thing happens out here, and same things happens out here also. Okay, so whenever we get this, straight away we will write the value as 1. So note down the standard limits. Okay, so let's continue with question number 8 part 2. This is your question number 8 part 2. E to the power x minus x minus 2 log 1 plus x divided by x into sin x. Okay, so let us first check the limit. E to the power 0. E to the power 0 is 1. E to the power minus 0. Now e to the power minus 0 is 1 divided by e to the power 0, which will be 1. Okay, so 1 minus 1, 0. Minus 2 log 1, because it's 0, so log 1 is again 0, so the numerator is 0. And 0 into anything is always 0, so hence it is which form? 0 by 0 form. We have identified the form, it is 0 by 0 form, it is an indeterminate form. Okay, but now the problem out here is in the denominator. Even though it's 0 by 0 form, I will not be using LH rule directly, because when I use LH rule, denominator is in product form, and when I differentiate it, there will be a long expression out here. Okay, so to get rid of that, what we'll do is, just now we have learned the standard limits, isn't it? Limit x tends to 0 sin x by x, or x by sin x, and here I can see that is x and sin x, so we'll try and make in the form of standard limits. Okay, how? Denominator is in denominator we have sin x. Now what I'll do is I'll multiply the numerator by x and multiply the denominator by x as well. Okay, so let's try it quickly. Multiplying the numerator and denominator by x. So what do I get is limit x tending to 0, the same expression, e to the power x minus e to the power minus x minus 2 log of 1 plus x divided by x into sin x into x divided by x. Okay, so now what will I do is, after this step, I'll separate this x and then sin x as one of the limit, and x into x square as another limit, like this. Okay, so limit x tending to 0, e to the power x minus e to the power minus x minus 2 log 1 plus x. I will just write x into x, the denominator x square, into, after that, this x by sin x, x by sin x. So now I have separated this term. Okay, and whenever there's a limit, I can always put the limit for this term as well as this term. Okay, so therefore limit x tending to 0, e to the power x minus e to the power minus x minus 2 log of 1 plus x divided by x square into limit x tending to 0, x by sin x. I hope you're clear with this. Okay, so therefore the value for this limit is only 1. So limit x tending to 0, e to the power x minus e to the power minus x minus 2 log 1 plus x divided by x. I hope you're clear with this, and into 1. Okay, so therefore now we are only left with this limit. Let us again check the form. Okay, denominator is 0, the same expression, so numerator is also 0, hence the form is, this is 1. Okay, so I'm writing in the next line. So limit x tending to 0, e to the power x minus e to the power minus x minus 2 log of 1 plus x divided by x square, and the form is 0 by 0 form. So as it is 0 by 0 form, now we'll be using LH rule out here. Okay, and I'm going to do the differentiation directly and then show you the video. Okay, so therefore, so as we identify the form, it is 0 by 0 form. Okay, so now what we do is we use the LH rule out here. So we use the LH rule out here, differentiation of e to the power x, e to the power x, differentiation of minus e to the power x minus into e to the power minus x, so minus and minus plus, e to the power minus x minus 2, differentiation of this, assuming this as x, so 1 by 1 plus x, and into this, in differentiation this is 1, so only remaining is this one, x squared 2x. Okay, now this is what I've left with. 2 is a constant, take it outside, so 1 by 2 will be the constant in the next step, which is this one. So 1 by 2 limit e to the power x plus e to the power minus x minus 2 by this divided by x. Now limit x tending to 0. Okay, so again when I put the limit for numerator and denominator is already 0. Numerator, this is e to the power 0, 1, e to the power minus 0, 1 by e to the power 0. So that's again 1, so 1 plus 1, 2, minus 2, and you put 0 out here. So 2 by 1, so I'm getting minus 2. 1 plus 1, 2, so 2 minus 2 is 0, divided by 0, so again it is which form? 0 by 0 form. So again we take the differentiation. Okay, so therefore after differentiation by LH rule, So using Elliott rule, what do we get? 1 by 2 remains as 1 by 2. Limit x and 0 remains as it is. Differentiation of e to the power x, e to the power x. Now plus sign is there. So minus sign is out here after differentiation, because 2dx of e to the power minus x, minus into e to the power minus x. That's why it's minus sign out here. Minus 2 and ddx of x plus 1 all to the power minus 1. We're taking the numerator. Okay. Differentiation of x is 1. Next step, there won't be any denominator. Okay. So 1 by 2 limit as it is, minus 2 using the formula x to the power minus x to the power n. So n x to the power n minus 1, so minus 1 minus n minus 2 into ddx of x plus 1 is 1. Okay, in the next step, so here there is no denominator, so 1 by 2, same, minus n minus plus x plus 1 whole to the power minus 2, so divided by 1 by x plus 1 whole to the power 2. Okay, the power becomes positive and into 1. Now we don't have denominator, so we don't have to check 0 by 0 form, just put the value for x. And x out here is 0. Okay, so 1 by 2 within the bracket e to the power 0 minus e to the power minus 0 plus 2 divided by, now x plus 1, x is 0, so 0 plus 1 is 1, so 1 square is 1 only. Okay, so half. Now e to the power 0, e to the power 0 is 1. Now e to the power 0, e to the power minus 0, that is 1 by e to the power 0, so 1 by e to the 0, it's again 1 and then plus 2. Once again I am repeating, e to the power 0 is 1, minus sign, put as minus sign, e to the power minus 0 means 1 by e to the power 0. So 1 divided by e to the power 0 is 1. So 1 by 1 is 1. So 1 minus 1 plus 2. Okay. So therefore 1 and 1 gets cancelled out, and then 2 and 2 also gets cancelled out. So the answer is 1. So this is how we do question number 8 part 2. 8 part 2, once again I am going from the beginning. Okay, so if we have a product form like this, x into sine x,